Okay, so now we're starting chapter 10, areas of all things. Bear in mind when we do areas, you've got formulas for everyone, so don't forget we need to do formula, line of working out, and then answer. So we started off in lesson 1, area of parallelograms and triangles. As you can see by the new vocabulary, you've got quite a bit, to be quite honest, but it's all that you've done: the base and the height of a parallelogram and the base of a height of a triangle. Now, also bear in mind that don't forget you can do this auxiliary line if you haven't got the height. And then don't forget also it's a right angle triangle, so things like Pythagoras might come into play, special right triangles might come into play, and so will trigonometry come into play. So be careful that you may have to do extra work in order to find the height. So as you can see in example 1, they want you to find the perimeter and the area. So you've got two things to do. The perimeter is obviously the easy part, it's whatever the outside of the shape is. Make sure you've got the two sides and the two opposite sides, so you can add them together to make whatever it is, in this case 21 inches. But to find the height, don't forget the first formula is base times height. The second line is showing you working, and then third line would be your answer. So make sure you've got formula, line of working out, and answer. Okay, so we're moving straight on to example 2, and again look at what you've got. Straight away you've got one of these special right triangles, 45, 45, 90. Well, first of all, you need to find the area as well. So that's base times perpendicular height. So we know it's going to be the 15 times something. And if you take the fact that you've got a 45, 45, 90, and this is 8.5, remember that trick. To get from there to the leg, you divide by 2 and put root 2 next to it. So this would actually be 4.25 root 2, which is approximately 6. If you put it on your calculator to the nearest whole number, and then you're using this information that you've got here to multiply by the length, which is 15, so you'll finish up with 90. Alright, so now in example 3 we're going to put both of those together. We're actually finding the perimeter and area of a triangle this time. Okay, now don't forget the triangle is a half base times perpendicular height as far as the area is concerned. The perimeter is easy, you just add together the outside sides. Okay, so in this case it's a half times 7 times 9, which is 31.5. But the question is asking you that if you've got a bag of mulch, it covers 12 square feet, and your paving stones provides a 4-inch border, so how much would you need of each? Well, one bag, it's just put it as a fraction, so 1 over 12 feet, cross multiply, you finish up with 2.625 bags, or 2 and 5/8 of a bag. Do the same with your stones. Alright, 12 over 1 equals 1 over 4 inch, because that's how far it goes, which means you need 135 stones. But going back, you cannot buy 2.625 bags, you have to go to the next one, so you need 3 bags of mulch and 135 paving stones. Okay, so now let's have a look at a few problems. So let's have a look at what we need. First and foremost, we need the perimeter, we need the area, and to the nearest tenth. So that's 1 decimal place if you've got decimals. Okay, obviously if you've got whole numbers, you're okay. But let's have a look at number 1. Alright, well first of all, don't forget your perimeter is equal to 2 times the length plus 2 times the width. So that's 2 times 15 plus 2 times of your 13, and if you add 2 13s are 26, 2 15s are 30, and if you add 26 and 30 together you get 56, and don't forget it's inches squared. Alright, now before you start doing the area, you've got a little bit of working out, because you need the perpendicular height, because don't forget area equals the base times the perpendicular height. Well, we don't know what the perpendicular height is, but look at these numbers again. Alright, they're part of your Pythagorean triple. If the smaller side is 5 and the hypotenuse is 13, that means the height has to be 12 because it's a 5, 12, 13 triangle. And if you don't get that, then you've got to use Pythagoras, okay, which would then be 13 squared minus your 5 squared. Put everything in and you'll still get your 12. Okay, now you can do it because it's 15, and don't forget the base is the same as this guy. 15 times your 12, so that will give us 180, and that's going to be inches squared. Okay, so let's have a look at number 6, because we're going to do a bit of fiddling about with this, to be quite honest. Again, we need, first and foremost, we need the height to find the area of the triangle, and we also need it as part of the perimeter. But let's have a look again. Again, look at these guys. If you divide those by 4, you get that this will be 3 and that will be 5. So you know that this is a 3, 4, 5 triangle. So multiplying it up, the height must be 16. Well, we were okay now to do the area of the triangle because that's a half base times height, which is a half times 30 times 16. Okay, and if you do that, you finish up with 240, and this guy is millimeters squared. All right, but now we still need this bit here. We still need this, which is your hypotenuse. So to find your hypotenuse, don't forget, this is going to be 16 squared plus 30 squared, and that will give you 34. And now you can find the perimeter because you've got 16 plus 30 plus the 34, which will give you a total of 64, 74, 80. So that will be 80 millimeters. And as per usual, as you can see, they take it one step further. Now we're in coordinate geometry. So now you've got your 3 points. So you plot it on your graph paper. All right. Now what you're looking for is either a horizontal or a vertical line. Well, this guy is horizontal, so you can just count as far as the height, the base is. Okay, so if you think about it, you're going from -3 to +4, so you know that that's a distance of 7, and then the perpendicular height is just from -1 to 3, which will give you 4. So the area is going to be easy to find. Okay, but the perimeter isn't. You know that this guy is 7, so you need to do the distance formula twice. Okay, so again, keep it in radical form if you want. All right, oh sorry, that's radical form, and then add them all